Hey friends, it's Mrs. Gregerson, and we are doing lesson 5.1. It's called the triangle mid-segment theorem, and I really like this lesson. It's not a very long lesson. We are going to be doing now just one more test before the end of the semester. We're going to have lesson chapter 5, and then we'll do 3 lessons from chapter 6, and then we'll review for like a week before finals because we want you guys to have plenty of time to review, ask questions, and get prepared. But the nice thing is today, this day's notes is kind of, if you memorize your theorem, it's not too hard. So let's first of all start out with our property of what a midsegment is. What is it? A midsegment is a segment that joins the midpoints of two sides of a triangle. For instance, down here in this diagram, segment XY is a midsegment, segment YZ is a midsegment, and segment XZ is considered a midsegment because notice every one of these points are midpoints of a side. So every triangle is going to have 3 midsegments. Now those 3 midsegments form what we call the midsegment triangle. And it's just a way for us to refer to this triangle. Now the cool thing is lots of neat properties end up as a result from this. And a lot of it's using what we know about congruent triangles, angles, some really cool stuff that's going to work out. So first of all, there's two things you always need to assume when you're given a midsegment, all right? A midsegment of a triangle is these 2 things. First, one, parallel, all right? So we're going to use the word parallel to a side of the triangle. So the midsegment is going to be parallel to the side of a triangle. So the first thing it's going to do is you're always going to know you're going to mark parallel. Now, when you think about that, all these properties of parallel lines should come through. And the main ones you should remember would be corresponding angles. So if that's the case, these 2 angles right here, angle BDE and angle A, would be congruent. Your other pair of corresponding angles right here would also be congruent because those are corresponding angles with parallel lines. So kind of a cool thing happens when we have parallel sides. Now the other thing that's real important is to understand if I have a midsegment, which DE is here, it is half the length of the parallel, and I'm going to put that in parentheses because it just says half the length of the side. Now which side are we talking about? The side it's always not going to be touching. So a midsegment is not going to touch obviously one of the sides of a triangle, so it's half the length. So notice here they always say, hey, if you have a midsegment, which you're going to the 2 midpoints, and notice you have the congruency marks to show that because midpoints give you 2 congruent segments, then you know it's half the length. For instance, if AC is 10, half its length is 5. So you should either go both ways. You can either double the midsegment to get the side it's parallel to, or you take half the side it's parallel to get the midsegment. It goes both ways. Now, let's work with some examples on here. First things first, let's make sure we have exactly what we want in our diagram. One of the things that's harder to see here are the tick marks. So let's go ahead and get the tick marks here on that diagram. Look to see if you're getting midsegments formed. Midsegments don't always form. So I look here, I'm like, oh yes, those are congruent, those 2 are congruent, good. Both of these segments, PM and PN, are midsegments. I didn't draw the 3rd one in. Not a big deal, all right, so we can have that. So make sure you get those. Now also look to see lengths of segments. This angle right here is the 102 degrees, so I'm going to put that right there so we're not going to get that confused. But here's a few things we need to remember. Always mark up the 2 parts you know. For instance, I know MP is going to be parallel to LK, the side it's not touching. All right, so I know these 2 segments are parallel. Now, I also know that PN has to be parallel to the side it's not touching because they're midsegments. So that also is true. So don't ever forget the parallel lines. And we also know their lengths. So let's look at the very first thing here. For instance, the length of segment JL. Well, JL is this whole side. I don't know it. I'm going to call it X. Now, which side is it parallel to? Which mid-segment, excuse me, let me change that. Mid-segment is it parallel to? Segment PN. So I know it's 1/2 the length of segment PN. So it's going to be 1/2 of 36. It equals 18. Oh, excuse me, I just did that wrong. I just totally went brain dead. Scratch that. I was thinking opposite. PN has to be doubled to get JL. So let's look over here and make sure I put the right thing down. Please forgive me on the notes part. Sometimes I'm half awake. I didn't drink all my coffee yet. PN is half the length of segment JL. So to find JL, I have to double it. So I got 2 times 36, which equals 72. Now I'm on the right page. Don't like it when I'm not there. Now, let's look at the other one. This is where I was kind of thinking ahead. On segment PM, remember, PM is the mid-segment. Now, which side is it parallel to of the original triangle? LK. I know its length. Okay? So if I know the longer one's length, don't have to divide it in half. So here's where I was totally spacing out on. I know the length of segment PM is half the length of segment LK. What does that mean? That's 1/2 of 97. That's the same thing as 97 over 2. What does that get us? 48.5 for those of you who like it, or you can leave it as 97 over 2, as long as they're reduced. Now, one other thing that we're going to be asking is angle measures, and that's because we have our parallel lines. Now, I want to know right here, and I'm just going to call it Y for time's sake. Let's do it in red so it's a little bit easier to see. I'm going to call it Y, MLK. Now, what would MLK be congruent to? Well, remember, we have parallel lines. So I have these corresponding angles that are being formed. And what do we know about if I have parallel lines, then corresponding angles are congruent. So that means it has to be 102 degrees. Why? Because the measure of MLK is equal to the measure of angle LMP because of parallel lines. All right, so think of it in that sense because they're corresponding. All right, now we're going to go to the next page.